Show that the system of equations below results in a line of solutions and find the equation of that line. We have 5x plus 3y plus z is 13, 2x plus y plus z equals 6, and negative x minus y plus z is negative 1. The first thing to note is that none of the left-hand sides is a scalar multiple of any of the others. So we don't have the same plane, we don't have any parallel planes. So let's call them 1, 2, and 3. And looking at the coefficients, I think it's going to be easiest to eliminate z. So if I do equation 1, take away equation 2, 5x take away 2x is 3x, 3y take away y is 2y, the z's are going to disappear, 13 take away 6 is 7. Now if I do equation 2, take away equation 3, 2x take away negative x gives me 3x, y take away negative y gives me plus 2y, the z's disappear and 6 take away negative 1 gives me 7. We've got the same equation, 4 and 5 are the same. These are consistent equations and indicate that we'll get a line of solutions. So now we're tasked to actually find the equation of that line, which is sometimes a bit of a fiddly mess. And so if you spot a better way through this mess than I've got, good for you. So what am I going to do first? The first thing I'm going to do is take one of these equations and I'm going to rearrange it so that I've got 2y is equal to 7 take away 3x, and then I've got y is 7 take away 3x divided by 2. And that's important, so I'm going to label it number 6. I'm also going to rearrange it the other way here. So what I'm going to do is say 3x is equal to 7 take away 2y, and therefore x is equal to 7 take away 2y over 3. And I'm going to make use of that as well. And what I'm going to do is choose what I think is the easiest of the three equations to work with now, which is number 2. So equation 2 becomes, so that 2x, I'm going to replace it from here with twice 7 minus 2y on 3, and then I've got plus y plus z is equal to 6. So that's going to give me 14 take away 4y over 3 plus 3y over 3 is equal to 6 take away z. Now this becomes 14 take away y on 3, and that's equal to 6 take away z. So 14 take away y would be 18 take away 3z. Negative y is then 4 minus 3z. So y is equal to 3z take away 4. And I'm going to call that one number 7. And if we look at 6 and 7, they both say y equals. One of them's in terms of z, the other one's in terms of x. So we can say 7 take away 3x over 2 is equal to y, which is equal to 3z take away 4. So 3x take away 7 over negative 2 is equal to y over 1, would be equal to z take away 4/3 divided by 1/3. So what I've done is I've taken that and I've multiplied top and bottom by 1/3. Now if I do the same sort of thing with the left hand side here, I get x take away 7 over 3 over negative 2/3. is equal to y over 1 is equal to z take away 4/3 over 1/3. And then from our work on vector equations, we can say that r is equal to 7/3, 0, 4/3 plus lambda negative 2/3, 1, 1/3.